Hello, my dear students. Welcome to BYJU'S Exam Prep. Very good morning, all of you. Good morning, students. Good morning. Please do let me know whether my audio and video is all good, all perfect. Good morning. Let me check from my end also. I think everything is good, right? Okay, let me check. Yes, good morning. Good morning. Good morning. So, only 3 days, I would rather say only 3 days left out for your GATE examination. Good morning, Hemang. Good morning. Good, sir. Good morning, Sanket. Good morning. So I hope at this point of time, all the subjects being revised. Now you should be only doing a revision, not required for any mock test, right? Just have a only basic revision. If required, you can give some previous any questions which you have already attended. Just you can have a go through about that. Good morning, Naveen. Good morning, Avni. Good morning. So, today we'll be talking about industrial engineering, the complete formula math and series. Specifically, if I say from this subject perspective, we are not having that much of formulas, but yes, whatever formulas we'll be having from the different topics, we'll be covering that, and we'll be trying to understand some special conditions also. Okay, so let's begin the session, and I hope it's all good, all perfect, and everyone is waiting for this particular session. Okay, so I think this is not required any introduction. I hope you all know about me. Okay, good morning, good morning. And those who are not yet connected with me, please do connect on my Telegram channel, that is Mechanical by Sooraj Gopi. Okay, where you can get the daily dose, you can get the PDFs, you can have a direct interaction with me. Okay. Now, Sanjay Rathi sir, who is 3 times ESE qualified, will be coming live today at 7:30. And those who are planning for GATE 2024, definitely you should be watching this session. For that, you need to register yourself on the in the description. Also, you'll be having one link. Now, the big event. Okay, Naveen. Okay, definitely. The big event, the day of examination, 4th Feb, 6 p.m. We'll be coming live and we'll be having the discussion of all the questions, all the we can say doubts you might be having. Right after the examination, the first step that you should be doing is you need to cross check what is your answer, right? So we'll be coming up live just after half an hour, because after 5:30 the exam will be over. Around 6 p.m. on 4th Feb we'll be coming live, and we'll be having the complete discussion of the examination. And the best part is only one exam, so definitely we won't be having variations. Only one paper, all same for all the mechanical students. Okay, good morning Malesh, good morning Bhaume, good morning. Fine, so shall we begin? Yes, we'll be having a quick revision when like 60 minutes or 90 at max, 1.5 hours will be more than sufficient to have the complete formula revision. We'll be starting from the PERT and CPM, right? So let's begin with PERT and CPM. Let us start with PERT analysis. Let us start with the PERT analysis. Now, if I talk about PERT analysis, as we know that PERT is a probabilistic model, right? So definitely we are having, for any activity, we are having 3 time estimates. Okay, we are having 3 time estimates, right? So I'll be asking you some questions. You have to respond me, right? For any activity, right? There are 3 time estimates. Can you tell me what are the 3 time estimates? For defining any activity completion, we are defining 3 time. We are having the optimistic time, we are having the pessimistic time, we are having the most likely time, right? And we know that all these time estimates is always following a beta distribution. Is always following a beta distribution, right? So if it is following a beta distribution, so if I want to calculate what is the expected time of completion for an activity, that will be equal to the optimistic time plus 4 times of most likely plus pessimistic time divided by 6. Because here every activity, the completion time is not we are not having an exact completion time, right? Okay, perfect, right? So in order to tackle out this particular conditions, because PERT is a probabilistic model, so what we do, we try to have one time estimate, which we call it as expected time of completion for an activity. Expected completion time time for an activity, right? Okay. Yes, fine. So we have calculated TE, and if I try to plot the graph, you are able to see on the screen, right? Let me hide myself. This is the optimistic time, which we call it as TO. This is the pessimistic time, that is your TP. This is your most likely time, which is having the highest probability. This is the most likely time, right? Which is having the highest probability. So if I want to calculate on an average, the TE value will be somewhere around here, right? So TE is coming out to be TO plus 4 times TM plus TP divided by 6. Now, as we know that, as this is, good morning, Ajay, good morning. As we know that this is a probabilistic model, so definitely we'll be having some standard deviation. We'll be having the standard deviation, right? Quickly, you have to tell me in the comment section. If I want to calculate the standard deviation for an activity, what will be the formulation for an activity? That means what is the maximum variations happening, right? So it will be TP minus TO divided by 6. If I want to calculate the standard deviation for an activity, it will be the difference of pessimistic time minus optimistic time divided by 6. Okay, so now what we have discussed, we have all talked about the activity. We have talked about the expected completion time. We have talked about the standard deviation. Now, if I want to calculate for a complete project, so for a complete project, how we can calculate the expected completion time, that is your capital T. This capital TE we are basically getting from the critical path. This capital TE is basically we are getting from the critical. What is capital T? This is the minimum time to complete we can say project, or we can say it is the longest time consuming path in an entire pathway. Okay, in the entire network, that is the maximum time consuming path, or we can say this is the minimum time to complete a project, right? Okay, so I hope so you know how to calculate the critical path. No revision, because in the marathon sessions also we have already discussed. So this is basically for our formula revision. So we will be taking some formulas. So let us suppose if I say capital T you have calculated from the critical path. Let us suppose that TS is the scheduled time, right? As we know that the project always follows a normal distribution. It is always following a normal distribution, right? So if I try to plot the graph, a normal distribution curve, right? So this is your capital TE, this is the capital TE, right? So if I want to calculate what is the probability of completing, a project in schedule time, that is TS. So how we can calculate that? For that we need to define one very important term, which we call it as standard normal variate. Z basically signifies the standard normal variate, and how we calculate standard normal variate is nothing but the difference between the scheduled time minus the expected time divided by the standard deviation of the project. Okay, standard normal variate basically we can calculate by using a very interesting concept of standard we can say standard normal variate, that is TS minus TE divided by standard deviation of the project. Now TS we know it will be given in the formula. Capital T we already calculated from the critical path. The question is how we can calculate the standard deviation of the project. Can anyone who can tell me how we can calculate the standard deviation of the project? Anyone? Heyman? Because this is a quick revision. So let's have a quick revision of the subject. Okay. Can anyone who can tell me how we can calculate the standard deviation of the project? It's quite simple. It is nothing but it is the under root of sigma is equal to VP into 0.5 to the power 0.5. Exactly. Root of variance. Perfect. So it is basically under root of the summation of the variance. Are we talking about the variance of the entire pathway? Are we talking about the summation of the variance of all the activities? No. We are only talking about for the critical path. We are only talking about the critical path. Is this clear? The sum of the variance of all the activities only along the critical path, not for all the pathways. Okay, or we can say it is nothing but under root of the summation of the square of the standard deviation of the critical path. Right? Is this clear? Understood? Either we can calculate by using the variance direct, and how we can calculate the variance? How we can calculate the variance? Yes, we can calculate the variance. Variance is equal to, for any activity is basically equal to TP minus TO divided by 6 whole square. Okay. For any activity, we can calculate the variance value by using a very simple formulation. It is basically the square of the standard deviation. We all know that. Okay. So variance of any activity is equal to TP minus TO by 6 whole square. So from there, I can calculate variance for all the critical activities. Just we need to take the root of this. They'll be getting the standard deviation of the project. And once we are getting the value of sigma of the project, T, S and T, we have calculated, we can calculate this value of Z, that is standard normal variate. Okay, standard normal variate. Now still, how we can calculate the probability? Based on some values of Z. Now we have already seen that when Z is equal to 0, what is the probability of Z equal to 0? Anyone? What is the probability when Z equal to 0? It is directly 50%. Okay, when you are having Z equal to 1, that is the standard normal variate, when it is equal to 1, probability of Z equal to 1, it is approximately 84.3%. Okay, fine. If I talk about Z is equal to 2, so we can say probability of Z equal to 2. Very good, very good. Approximately we can say near about to 98%. Fine. Okay, now we know that the best part of normal distribution is it's always symmetrical about the center axis. It is always symmetrical about the central axis, right? So we can say, if I want to calculate what's the probability of Z equal to -1, I can say it is nothing but the complementary or the conjugate function. This is probability of Z equal to 1. So this is 1 minus 0.84, that is 16%. So probability of Z equal to -1 is coming out to be 16%. Is this clear? Approximately 16%, and probability of Z equal to -2, approximately we can say 2%. Is this clear? Okay, these are some small points that you need to remember, because you will be getting questions from these particular terminologies, right? So what we have discussed that let's say this is a complete table. No need to remember the entire values. Only these values are self-sufficient. Only these 5 values are self-sufficient. Okay, Z equal to 0, Z equal to 1, 2, Z equal to -1, Z equal to -2. Right? We can remember one more value as when Z is equal to 1.45 or 1.6, somewhere around that, you will be having 95%. Okay. If your standard normal variate is approximately equal to 1.45, then we can say it is not approximately equal to 95%. Okay, fine. Is this clear? So this was all about the Pert analysis. Now let us talk about the critical path method. Now in critical path method, basically what is happening is, in this case, this is a deterministic approach. As we know that this is a deterministic approach, right? So definitely what we can say that here, for every activity will be having only one time of completion. Every activity will be having a single time of completion. So what we can say that here there is no concept of optimistic, pessimistic, or most likely, or beta, or normal distribution. Okay, here what we are doing is we are basically trying to identify the crashing method. We are trying to identify the we can say float value. Okay, so let us suppose if I want to calculate the float. Okay, and what is a float? I hope everyone knows what is a float. It is basically the amount of duration by which an activity can be delayed without affecting the project completion time. Okay, without affecting the project completion time. This is basically we call it as float. Now, let us suppose, now float is basically defined under three categories: total float, free float, and your independent float. Now, if I say in general perspective, if I'm having I, this is J, this is EI, LI, EJ, LJ, the duration of completion is Tij. So how we can calculate total float? I have always told you a short method to remember the formulation. How we can calculate the total float? Total float is nothing but Lj minus the latest finish time minus the earliest start time EI minus Tij. This will be giving you the total float. It's very important because in the question you will be getting questions directly. They'll be asking either the total float or free float or the independent float. And what is total float? Is the difference between the maximum time available and the actual time required for the completion of an activity. That means by how much duration an activity can be delayed such that the project completion time is not being affected. Okay, so total float we can easily calculate by using this formulation of Lj minus EI minus Tij. What is Tij? That is the activity completion time. Okay, and now we can obtain this value by having the forward and backward pass computation. I hope everyone knows. If you're not knowing, please do let me know. We can take one example. I hope everyone knows what is forward pass computation, what is backward pass computation. Is this clear? Right? Chalo, now let's talk about free float. How we can calculate the free float? Let's say this is I, this is J, this is Tij. So this is EI, LI, EJ, LJ. So if I want to calculate free float, please tell me in the comment section. I told you how we can identify the value of free float. Yes, everyone. Krishna, Ajay, Sanket, Rajesh, Hemang, Bhomik, Sujish, Malesh. What is the formula to calculate the free float? Free float is basically the amount by which activity can be related without affecting the earliest start time of the succeeding activity. Okay, so we can say it is nothing but EJ minus EI minus Tij. You have to take only the earliest time, that is EI and EJ, difference of this minus Tij. For this formulation, we can calculate the value of free float. Never ever have any difficulty. We always, many students do have confusion. So I've always told you how we can remember. For total float, you have to take the cross calculation, Lj and EI. This one and this one, right? If I talk about free float, only you have to take the earliest value, EJ and EI. If I talk about the independent float can be written as, if I write it like this, I, J, EI, LI, EJ, and LJ, right? So I can say, if I say Tij is the duration of completion. So the independent float is simply you have to take the difference of the latest time. That means this the lower value, that is Lj minus Li minus Tij. Okay, by this formulation you can easily calculate what is independent float. Okay, is this clear? Very easy. And what is the meaning of independent float? It is basically by how much an activity can be delayed such that its preceding latest finish time is not being changed. Okay, fine. Is this clear? It is the amount by which an activity can be delayed when all the preceding activities are completed as late as possible such that its succeeding activities are started as early as possible. That means by how much duration an activity can be delayed such that its previous activity is not being hampered. If I talk about the free float, it is basically by how much duration an activity can be delayed so that its succeeding activity is not being hampered. Okay, and if I talk about total float, what is total float? It's nothing but it's the duration by which an activity can be delayed such that the project completion time is not being hampered. Okay, three very important discussion of the floats. Now let us talk about the crashing. Now let us talk about crashing. Crashing of an crashing of a project. Okay. Now what is crashing? Now tell me, crashing we can do in CPM or or in Pert analysis. Succeeding, actually it is basically saying independent float is basically, we can say, the duration by which the previous and the succeeding activity is being started as early as possible, right? That means if I take one example, over here, let us suppose I'm having an activity 1, 2, 3, something like this. Let's say this is A, this is B and C, this is 2, this is let's say 4, 6, then this is 8. Okay, so if I talk about this, the critical path will be 1, 3, this one, right? So if I say activity B, if I talk about activity B, if I try to understand the logic of independent float is basically by how much duration this activity can be delayed such that its preceding activity it's not being hampered. And there is one more formulation, because the statement is saying all the preceding activities are delayed as late as possible and all succeeding activities are started as early as possible, because it's a very simple formulation. If you try to subtract the head event slack from the free float, we are getting the value of independent float. Okay, if I try to subtract the free float, we can say the head slack from the free float, will be getting the independent float, right? And that is basically written all the succeeding activities are started as early as possible. You cannot we can say we can start a succeeding activity without having any delay. Okay, is this clear, Sujesh? It's quite simple. If I try to understand from a very basic understanding, free float and independent float, there's a relation between free float and independent float. If I try to subtract the head event slack and the tail event slack, right, from the total float, if I try to subtract the head event slack, we'll be getting the free float. If I try to subtract the tail event slack from the free float, we'll be getting the independent float. And that is basically the understanding of the independent float. Okay, now let us talk about the crashing method. Now if I talk about the crashing, the first question that you will be asking is, crashing is done in Pert analysis or the critical path method? Tell me, crashing is being done in CPM or in Pert? Anyone? Crashing is done in CPM or in Pert? Always remember that crashing is always done in critical path method, not in Pert analysis, because we always know Pert analysis is a probabilistic approach. There we don't know what is the exact completion time of a project. In CPM, we know what is the exact completion time. So crashing is always done in a CPM method. Now, what is crashing? Now, what we are doing is we are defining two very important costs. That is your direct cost and indirect cost. Achha, what is the difference between direct and indirect? Direct cost is basically those costs in which if you are we can say increasing or decreasing the resources, its time of completion will be directly hampered. That means the direct cost is basically those costs which is directly influencing the activity completion time. Okay, indirect cost is basically those costs which is not directly influencing, but it's still an important factor for completing an activity. The best example is if I talk about the manpower, if I talk about the raw materials, okay, all these costs which is directly impacting the completion of an activity, which we call it as a direct cost. Indirect cost will be, we can say, the salary of the employees, okay, or we can say the daily allowances, right? So where the completion of an activity is not directly being impacted, that kind of cost we call it as indirect cost. Okay, so here if I talk about a very basic understanding, as we know that as the direct cost is directly being influenced, so here we will be plotting a graph. Okay, it's quite easy. Let us suppose that there is an activity A which is completed in let's say 10 days, and for completing this activity only one person and one machine is required. But what has happened, like I have increased the manpower from 1 to 3, right, and increase the number of machines. By doing so, we can complete this activity in, let us suppose, in 3 days. Okay, so this process in which I have increased the resources, and by doing so, what has happened, I'm increasing the cost, and that cost is basically, we're talking about the direct cost. That is basically the direct cost. Is this clear now? Crashing is always being done on the direct cost. Okay, fine. Now let us suppose initially for 10 days it was costing me rupees 1000, right, and for 3 days it is costing me let us suppose 1700. Okay, so can you tell me per day what is the additional cost that I need to pay? If that A activity which was supposed to be completed normally in 10 days and it was costing me rupees 1000, right, so when I'm completing in 3 days it is costing me 1700. So can you tell me on an average what is the per day cost that I need to bear if I want to crash by 1 day or 2 day? Anyone? How we can calculate? So let us suppose I'm denoting that the normal time of completion is 10 days, right? The normal cost is rupees 1000, right? If you're crashing to 3 days, the crash cost will be costing me rupees 1700. Okay, fine. So there's a very important assumption that we are making is whenever we are plotting, whenever we are having the discussion of the direct cost versus the time, it will always follows a linear we can say approximation. We always say that if I say this is your let's say normal time, corresponding to this will be having some normal cost. Let's say this is your normal cost, right? So when I'm crashing to a smaller value, it will be having some larger value, that is we are say crash cost. So it will always follows a linear approximation. This is a very important assumption that we're making. So can we say what is the slope of this particular curve? Slope, we can say delta C by delta T, that is equal to we can say crash cost minus the normal cost divided by the normal time minus the crash time. By using this formulation, we can calculate the value of slope, and this slope we call it as the crash cost slope. Crash cost slope. Okay. Now, why this is important? Whenever we are doing crashing, the first very important thing is we are doing crashing only for the critical activities. Okay, fine. We are always doing crashing only for the critical activities, and we always select that critical activity which is having the least crash cost slope. Okay, what is the meaning of this? If I try to place this value, you'll be getting 1700 minus 1000 divided by 10 minus 3, so it is 100. That means I have to pay 100 rupees additional if I'm crashing by 1 day. That means if I say if I'm completing this activity in 9 days, can you tell me what is the total cost that I need to bear? If I'm completing this activity in 9 days, can you tell me what is the total direct cost? Yes. If I'm completing this activity in 9 days, it will be costing me 1000 plus 100, that is 1100 rupees. Let us suppose I'm completing this activity in 5 days. Can you tell me in 5 days it will be costing me how much in 5 days? What is the total direct cost? 1000 plus it is being crashed by 5 days, so 5 into 100, so it will be costing me 1500 rupees. Okay, so by this way I can calculate the total direct cost. I can easily calculate the direct cost by using a very easy concept of crash cost slope. Okay, and we are crashing only that critical activity which is having the least crash cost slope. Is this clear? Fine, right? And ultimately what we are doing, we can calculate the total cost. Total cost will be equal to the summation of the direct cost plus the indirect cost. Summation of the direct cost plus indirect cost, and indirect cost is always in rupees per day. Okay, it will be always be given some value. If you're not able to understand how to recognize direct and indirects, there's a simple technique that the indirect cost will always be given in rupees per day. That means the daily cost. If you are crashing, if you are, let us suppose, reducing the project by 1 day, then your indirect cost, whatever amount we are having, it is being reduced by that amount. If I say the indirect cost is rupees, let's suppose 500 per day, and if you are crashing that project for 1 day, if I'm crashing that project for 1 day, that means you are saving 500 rupees directly by using this indirect cost concept. Okay, fine. So this is all about your PERT and CPM, where we have discussed about the CPM, we have discussed about the PERT analysis, the float, and we have talked about some basic understanding. Now let us talk about the break-even analysis. Now, what is the meaning of this word break-even? That is basically, we can say this is no profit, no loss condition. Break-even is no profit, no loss condition. So how we can identify? Let us suppose if I say total cost is basically total expenditure. Total cost or total expenditure is nothing but the summation of the fixed cost plus the total variable cost. What is fixed cost? Fixed cost is basically that cost which is not changing whatever amount of volume production you are doing, right? If I say, if I'm plotting the fixed cost versus the volume of production, so it will always form, what is a graph? If I want to plot a graph between fixed cost and the volume production, can you tell me what that graph will be looking like? It will be a horizontal line or a vertical line? It will simply a horizontal line, because whatever you are manufacturing, whatever volume production you are doing, it is independent. You have to pay that minimum amount. That is basically the fixed cost. If I talk about variable cost, it will always follows a linear approximation. It will always follows a linear approximation. That means it will be having a curve like this. So if I try to club these two, so total cost or total expenditure, we can say the total expenditure. Expenditure means the total cost that I need to bear. So if I try to plot in a single graph, it will be having a graph like this. This is your total cost, right? This is the fixed price. This is the fixed price or fixed cost. This is the variable cost. Is this clear? This is X versus total cost. Okay. So if I ask you one very easy question, when you are having zero volume of production, are we having any cost? What is the value of total cost for zero volume of production? What is the value of the total cost at zero volume production? Can you tell me? Where F resembles the fixed cost, X resembles the volume of production, right? And small v resembles the variable cost per unit. Yes, can you tell me, if you are having zero volume of production, do we have any total cost magnitude? It will be simply fixed cost. You can place it when X equal to 0, total cost is directly equal to F. That means if there is zero volume production, still we need to pay some value, that is basically the fixed cost, or we can say initial cost or fixed cost, whatever you're doing. Like we can say fixed cost will be the rent value. If there is a machine you have purchased on rent, one day you are manufacturing 1 lakh unit and second day you are only manufacturing 10 units. So do I need to pay lesser amount of rent when I'm manufacturing lesser quantity? It's not like this. It is irrelevant. Whatever volume production you're doing, you have to pay a fixed amount of rent, which is not having any linkage with the volume production. And that cost we call it as a fixed cost. Okay. Now this is all about when I'm talking about the total expenditure. So definitely we will be having some returns also. We'll be having some revenue. So if I talk about revenue, revenue, or we can say sales, which I'm denoting it as capital S. So sales is equal to small s into X. Okay, where small s represents the selling price per unit. Okay, X is basically volume production. So I can say in general case, the total revenue is equal to total cost plus profit. P is basically profit. Okay, fine. So we can say small s into x is equal to f plus small v into x plus p. So this formulation we can use in any question from any perspective, any point of time. Okay, there is no limitation. But if I say at break even point, and what is break even point? What is break even point? Break even point is basically a no profit, no loss condition. No profit, no loss condition. That means P will be equal to 0, or you can say Sx is equal to f plus small v into x, or I can say x break even point will be equal to the ratio of fixed price minus S minus V. Okay, we can calculate the volume production in break even, and how we can identify in the graph. If I try to plot the graph, it will be something like this, right? This line represents the total sales. This red line represents the total sales, and this line, if I try to draw another, this black line is basically resembling us about the total cost. Okay, and this point where there is no profit, no loss, because below this will be having a loss condition, above this point will be having a profit condition. So this is the break even point where we are having no profit, no loss condition. Is this clear? No profit, no loss condition. Okay, fine. So now we can say that at this point, this is your XBEP, and we have seen that XBEP we can easily calculate at break even point is equal to F upon the selling price per unit minus the variable cost per unit. And we can say what is small s minus small v. This is can also be written as unit contribution. Unit contribution. Okay, the difference of the unit selling price minus the variable cost can be classified as the unit contribution. And I can also say that capital S minus capital V, we can also do this, we call it as contribution margin. Contribution margin, very important, because this particular concept will be used in the profit volume ratio. The contribution margin, which we are denoting it as CM, okay, which we can denote it as CM. So contribution margin, nothing but the total sales minus the total variable cost. That difference we call it as a contribution margin. Okay, fine. So let us talk about very important thing, that is your margin of safety. What is margin of safety? Now, let us suppose we know that at this point there is no profit, no loss, that is a break-even point. So definitely in any manufacturing plant, we try to manufacture much higher value as that of break-even point, because at break-even point there is no profit, no loss. So for having some safety, for having some factor of safety, we always try to manufacture slightly more value than that of the break-even point. So that additional factor of safety that we're using, we call it as margin of safety, right? So if I try to understand, if I try to explain with the help of this graph, okay, this is your total cost. This is the total cost or sales, right? This is the total sale. This is the total cost, right? Let us suppose this is the XBEP, X at break-even point. X resembles the volume production. If I say I'm manufacturing, let's say X value. So at this point, we'll be having a profit or loss. If I'm manufacturing this X units, are we talking about profit condition or loss condition? Definitely, I'm going much higher value than break-even point. That means I'm talking about the profit condition, right? So if I try to take the difference between these two, that we call it as the margin of safety in terms of units. Okay, so I can say margin of safety is equal to X minus X at break-even point. This is the factor of safety or margin of safety that we are using. Additionally, what we can say, we can calculate with respect to the sales perspective, because this point will be your SBEP. This is at any X value. I can also say the margin of safety from sales perspective is equal to SX minus SBEP. Okay, SX minus SBEP. This is the margin of safety from the sales perspective, right? Sometimes what happens, they are giving the margin of safety in percentage, okay, right? sometimes they're giving the margin of safety in percentage. So that will be the margin of safety percentage will be, if I say from sales perspective, that is equal to Sx minus S break even point divided by Sx. If they're giving in percentage, right? Sometimes in some numericals, you'll be coming up in percentage. In that case, you have to take with respect to at some full capacity or some at any specific volume production, that is Sx. Okay, now after this, we need to understand profit to volume ratio. Now, what is profit to volume? What is the significance of profit to volume ratio? Anyone? Profit to volume ratio is basically being used whenever we are dealing with multiple products. I hope so everyone remember that image that we have already discussed of Nestle, right? We are having chocolate, we are having ketchup, we are having coffee. When our organization is dealing with multiple products, right, there we are taking the concept of profit to volume ratio, because this will be telling us about which product is giving me more profit. It's basically a related term, right? So if I try to explain with the help of a graph, this is the volume of production, this is profit. Acha, what is the meaning of negative profit? Negative profit means we are talking about loss. If I talk about negative profit, basically we are talking about loss. So if I try to plot a graph, okay, if I try to, this line is basically resembling the profit to volume line, and this point where it is intersecting the x-axis, or we can say volume production, we call it as the break-even point. Okay, and this particular value is basically f. Sir, how we are getting a loss value of f? By applying a simple logic. S is equal to f plus capital V plus P. If x equal to 0, what is the profit you'll be getting? Anyone? If volume of production is 0, what will be the profit you'll be getting? You'll be getting this as 0, this is f plus 0 plus P, or we can say P is equal to minus f. That means I'm having a net loss of minus f, and that we are seeing in this particular graph. Okay, that we are able to see in this particular graph. And this PV line is always constant for a product. PV line or PV ratio is always constant for a particular product. So I can say the profit to volume ratio is equal to the ratio of the contribution margin by the total sales. What is contribution margin? Contribution margin is nothing but we can say sales, total sales minus total variable cost by sales. We know that S is equal to F plus V plus P, or we can say S minus V is equal to F plus P, or we can say F plus P divided by S. This is a very important relation that we need to remember. Okay, right? And we know that this ratio will be constant for a particular product. It will always be having a same value, constant value for a particular product, right? For a particular product, it will always be having a constant value, right? So can we say that P by V is equal to F plus P1 by S1. It's also equal to F plus P2 by S2. It's also equal to F by S at break even point. Yes. Can we write this relation? And why we have not written profit in the last term? Can anyone who can tell me why we have not written the profit in the last term? Yes. Why we have not written the profit in the last term? Anyone? Yes. A simple question. A very easy question I'm asking. Huh. Exactly, because that particular point is at we can say break even point, and at break even point we are having zero profit. We already know that, right? It is a no profit condition, no profit, no loss condition. That is the reason I have not written any profit. Exactly. Very good. Very good. And by using this relation, By using this relation, we can calculate the we can say any formulation. Like they will be asking what is a fixed price, they can ask you what is the we can say the break even cost, right? So they can ask you some easy questions over here. One second guys, there's some problem. Yeah, okay, is this clear? Fine. So this is all about our break even analysis. So we have covered two important segments. The third very important that we'll be starting right now is inventory. Now I'll be starting a very interesting, a very important term, which we call it as inventory. Okay. Fine. So let's begin. Let's begin this inventory topic. Now, if I talk about inventory is all about, we are talking about the different costs. We are having the purchase cost, we are having the ordering cost, we are having the holding cost, we are having the shortage cost, right? So we always coming across different type of costs, right? So if I talk about the inventory costs, if I talk about the different costs that is being associated in inventories, we are having the purchase cost, we are having the purchase cost, which we denoted as PC. We are having the ordering cost, which I'm denoted as OC, or we can say setup cost also. Setup cost. Third that we'll be discussing is your holding cost, which we are denoting as HC, and the fourth one is the shortage cost. Okay, we'll be dealing with these different types of cost in our discussion. Okay, so let's talk about the first very important model, the deterministic model, that is your economic order quantity, the basic EOQ model. EOQ basically symbolizes that is your economic order quantity, also called as Harris-Wilson. Also we can say this is basically your infinite replenishment model. I hope so you know why we are saying this as infinite replenishment model. Okay, so over here, if I try to calculate the purchase cost will be equal to what is a total annual demand into what is a unit price. That will be giving us the total purchase cost annually. This will be in rupees per year. Okay, if I talk about ordering cost will be equal to number of orders into the cost per order. Right now, how we can calculate number of orders? Number of orders will be equal to annual demand divided by the order lot size into CO. By using this formulation, we can calculate the total ordering cost in a year. This is the purchase cost. This is rupees per year. Right. If I talk about holding cost is nothing but the average inventory into the CH value, right? And if I try to do all the derivations, we are getting a very interesting, that is Q by 2 into CH. This is the annual holding cost per year. Annual holding cost per year. Okay, fine. So if I talk about the total cost or total annual cost, the total cost or total annual cost is the summation of purchase cost plus ordering cost plus holding cost. Okay, or I can say the total annual cost equal to, anyone who can, let me check. Okay, please, anyone who can comment right now. Is it all good now? There was some technical difficulty which happened. Yes, anyone? Yes, sir, all good. Okay, to check is this perfect with me or not. Okay, perfect. Yes, because there was some technical issue due to this. Okay, it's important. Please do let me know whether you are able to have a proper video and audio. Yes. If yes, don't know, then only we'll be continuing, or if no, then we'll be rescheduling the session. No worry about that. Okay. All good. Okay, perfect. So we were discussing about the total annual cost. Now, what is total annual cost? We can say this is equal to the purchase cost plus the total inventory cost. Okay, purchase cost plus the total. Won't be having much more, like half an hour more than sufficient to cover up the rest of the topics. We'll be having a quick discussion. Both good. Okay. So now we can say that the total annual cost is nothing but the summation of the purchase cost plus the total inventory cost. And what is this total inventory cost? Total inventory cost is basically those costs which is having that lot size, that is inventory is being depending. So it is only having the ordering cost, that is D by Q into CO, plus the holding cost, that is Q by 2 into CH. Okay, fine. So this is the formulation which you can use for any lot size. This formula that you are able to see on the screen, this you can apply to any lot size. Okay, there is no restriction to apply this formula. Okay, there is no restriction to apply this formulation, so you can apply it anywhere. Fine. But if I talk about economic order quantity, at economic order quantity, what is happening is the total annual cost will be minimum, or we can say the TAC will be tending to 0. So if I try to differentiate what we are getting a very interesting term, that is Q is equal to 2DCO by CH root of this, and this is we call it as the economic order quantity. So we can say that at economic order quantity at EOQ, the Q star is equal to, I'm talking about basic EOQ model. Basic EOQ model. Okay, I'm talking about basic EOQ model, right? So at basic EOQ, we can set economic order quantity 2 into D into CO by CH root of this will be your economic order quantity, that is EOQ lot size, or we can say TIC star is equal to 2DCOCH root of this, right? And I can also say the total annual cost at economic order quantity is D into C plus root of 2DCOCH. Is this clear? This all formula, whenever I'm using this star mark, that means I'm talking about economic order quantity. This is I'm talking about for basic EOQ model. Okay, now if I talk about and also we can say at economic order quantity, the ordering cost is exactly equal to holding cost. Very important, because we can understand from the graph also. If I talk about this graph, we can say this graph is basically the ordering, we can say the ordering cost, this is for the holding cost. At this point, what is happening when both are having an equal value, we are having the value of Q star. So we can say at economic order quantity, the holding cost is exactly equal to ordering cost. Very important, because sometimes you are getting questions directly from this formulation. Okay, fine. Is this clear? And if I talk about this particular curve, it will be having a total annual cost over here. Okay, this is for total annual cost, right? Done. Now let us talk about the second model, that is the discount model. Now in discount model, we always have very important understanding. We always feel some difficulty how to calculate the optimum lot size, because in the question they'll be asking you how to calculate the optimum lot size. Let me tell you a very important and interesting technique. What you have to do is, for the least unit cross, like say this is having, let's say C3, this is having C2, this is having C1, that is the unit price. C3 is having the least one. Okay, C3, let us suppose, is having the least one, right? So we need to identify whether the EOQ, whether the economic order quantity is feasible or not. If it is feasible, then that will be my final answer. If it is not feasible, then you have to cross check at the threshold value, and under threshold value where you are having the minimum most, that will be giving us the final correct answer. Like in this case, I'm getting the minimum at this point. Okay, I'm not getting minimum at this point, I'm getting minimum at this point. So whenever you are getting a question from the discount model, it's very important you are checking the feasibility. How we can check the feasibility? By using this formulation, Q star is equal to 2DCO by CH. By using this formulation, we need to identify whether that particular range that I have identified, the value of economic order quantity that we have identified, whether it's coming in the feasible range. If it is coming in the feasible range, it's good. If it's not coming, then you have to check at the threshold. Threshold means at the limiting value. Okay, let's say if there is an example from 1 to 499, let's say it is C, from 500 to 999, let's say it is C2, and from 1000 and above, it's C3. So definitely what we have to do, we have to identify the Q star value for this range. If it is coming in feasible, then that is the final answer. Let me give you a very easy technique. If you are calculating Q star for this range, if it is feasible range, it is coming in the feasible range, definitely that is the final answer. No need to check anything. But let us suppose if it is not coming in feasible, then you have to cross check over here, right? If it is again coming in feasible, then you have to check at this threshold value, that is 1000, and need to compare this 1000. And please, very important thing, you should be calculating the total annual cost. Okay, the common mistake that students are doing, they are not calculating total, they are calculating total inventory cost, which will be giving us a wrong answer. You have to calculate the total annual cost, and once when you are calculating for this 1000 value, I need to use this formulation, the general formula for any lot size, because if you are using the EOQ formula, that will be landing up with the wrong value. Okay, it's very important, you have to calculate the total annual cost exactly. If Q star is above 1000, then it is feasible. Definitely. Let us suppose this Q star is getting, let's say 1200, then 1200 is a final answer. No need to check anything. Let us suppose you are calculating Q star for this range, you are getting this value to be 1200, which is definitely in a feasible value, feasible range. So that is the final answer. No need to check anything, not even to check at this threshold value also. If it is not coming, right, let us suppose it is not coming 1200, it is coming, let us suppose in the second range, it is coming 700. So it is feasible over here. So you will be checking the total annual cost at 1000 units and at this 700. For 700, you can calculate directly by using this formulation. Okay, this is basically we can use for economic order quantity. Is this clear? Simple technique, very easy. No confusion, straight concept. Now, this is all about your discount model. Now, let us talk about very interesting, that is your production based model. Now, if I try to plot the graph, because the graph is very important. Let's say this is your time T, this is the inventory, right? So this is your production happening. Let's say this is your Q. Okay, this is TP. This is the time of production. This is the production rate P. This will be P minus D. And this is the demand rate. And this is the D. It is not an isosceles triangle. Please make sure. And this is your one time cycle. Okay, and one very important thing which we have skipped in this particular EOQ model, if I want to calculate N star will be equal to D by Q star. That is the optimum number of orders. This is your optimum number of orders, right? If I talk about what is the optimum time cycle, that is T star, that is equal to Q star by D, right? This is your optimum cycle time. Okay, and very important thing, always do check in which units they are asking. If they're asking number of days, try to convert that year into number of days, because this unit will be order per year, and here the unit will be year per order. That means one order is having how much duration. What is a time duration for one order? Normally by using this formulation we are getting in year. If I want to calculate in weeks, you have to just multiply it by 52. If you want to calculate in days, you have to multiply it by 365. Okay, small points that you have to cross check. Now, right, this is your one cycle. Okay, so over here, very commonly asked question is, you need to calculate what is a maximum inventory level. QM is the maximum inventory level. Maximum inventory level. That is the most commonly asked question from the production based model. Now, over here we can say QM is equal to P minus D into TP. Q is equal to P into TP. By using this formulation, we can simply say QM is equal to Q into P minus D by P. Okay, many times you are asked in the questions, there's been many times they're asking what is a maximum inventory level. So you can use this particular formulation and you can calculate what is a maximum inventory level directly by using this formula. Okay, fine. So here we are not having any ordering cost. Instead of ordering cost, we'll be having the setup cost, because here we are not procuring inventory from outside. We are manufacturing inventory in-house. Best example I told you every time, the tires of a car. Okay, fine. So we always try to manufacture. We always try to manufacture the inventory over here, right? So in this case, if I try to calculate what is the total annual cost, that equal to purchase cost plus setup cost is D by Q into CO plus holding cost is your Q by 2 into P minus D by P into CH. Okay, this is the only difference that we are. This is for any lot size. This is for any lot size, right? This is for any lot size. So if I want to calculate for EOQ at economic order quantity, if I calculate the Q star value, that is 2DCO by CH into P upon P minus T. There's a technique to remember. Always we know that the economic order quantity for a production based model, the economic order quantity for a production based model is always higher than that of basic EOQ. We can understand because we know that Q star for a basic EOQ is equal to 2D CO by CH only, right? And we know that basic EOQ will be having a lesser value than that of the production based EOQ. So we have to multiply with the factor which is greater than 1, and this P upon P minus D, it is greater than 1, and this we call it as a production factor. This factor we call it as a production factor. Okay, clear? So we can say P is a production rate. P is a production rate. Okay, let me write it in the previous slide. P is a production rate. I think this was a common thing. P is a production rate. D is the demand rate. TP is the time of production or production time. Okay, or production time. Okay, fine. So from here I can say the total inventory cost at EOQ for the production based model is equal to root of 2 capital D COCH into P minus D by P root of this, because we need to multiply with the factor which is less than 1, because the total inventory cost for production based model will be less than that of the basic EOQ, right? So we have find out that for a production based model we have seen some formulation. So if I try to compile for the production model, right, for production model for any lot size, at any lot size, we are having total annual cost is equal to D into C plus D by Q into CO plus Q by 2 into P minus D by P into CH. Okay, this is for any lot size. If I talk about economic order quantity, we can say Q star is equal to 2D CO by CH P upon P minus D root of this, and if I say TIC star is equal to 2D COCH into P minus D by P root of this. Okay, so this is at economic order quantity, this is at any lot size, the production based model. Okay, and if I talk about the total annual cost, again the same formulation, D into C plus TIC star. D into C plus TIC star. Okay. Now, if I talk about the fourth model, that is your shortage model. Now, in shortage model, what we are having, we are introducing very important thing, that is called as we can say shortage cost or back order cost. Back order cost per unit per time. Okay, CB is basically the back order cost per unit per time. Here we are deliberately keeping some shortages. So let us suppose if I say this is capital S, this from this point to this point is capital S, from this point to this point is capital Q, right? And this is the maximum inventory level. Let's say M, that is maximum inventory level. So over here, can you tell me how many costs will be introduced over here? How many number of costs? If I talk about total annual cost, we'll be having the purchase cost, we'll be having the ordering cost, we'll be having the holding cost. Along with that, we'll be having the shortage cost. There will be 4 different costs that will be associated in the shortage model. Okay, let me write it over here for shortage, right? So what is a purchase cost? That is annual demand into unit price. What is ordering cost? That is your we can say D by Q into CO. What is holding cost? Now holding, we are holding the inventory only for this time period, only for small time period. Let's say that is small t1. Let's say this is capital T, this is capital T, this is your small t1, this is your small t2, right? So if I try to implement, I won't be doing any derivation right now because already we have taken up the formulations. So I can say Q minus S whole square by 2Q minus S whole square into 2Q into CH plus S square by 2Q into CB. So by using this formulation, we can calculate the total annual cost for any lot size. This is for any lot size. Okay, this is any lot size. That is, I'm not talking about EOQ. So if I talk about at economic order quantity at EOQ, we can say Q star for a shortage based model is equal to 2DCO by CH into CB plus CH by CH, root of this, right? So this is basically, we call it as the economic order quantity for a shortage based model. Economic order quantity for a shortage based model, right? And if I talk about the TIC star, the total inventory cost at EOQ, we can say 2DCOCH root of this into C, it will be CB, not CH, it will be CB, CB upon CB plus CH. Okay, so this is the total CB, it's in CB. Correct, Hema. Right? Is this clear? So this is basically, I'm talking about for economic order quantity. But in the examination, are they going to ask you this much of lengthy problem? The answer is no. They won't be asking you this much of lengthy problem. They can ask you a question, what is the optimum number of units short? That is basically, we're talking about S star. They're going to ask you a question from this. Okay, they won't be asking you this lengthy problem. It's not they're asking you how you're able to remember the formulas. They will be asking you what logic you are able to remember. Okay, so if I talk about this one, so this is a very easy technique to get the value. Q star minus S star, because this will be the total units which we are basically storing. If I say this is Q, this is S, we are only holding this much, that is Q minus S. This is Q minus S, right? We are only holding this Q minus, this is the shortage happening, right? So we can say Q minus S star into CH is equal to S star into CB. So from here I can say Q star by S star is equal to CB plus CH by CH. So I can say S star is equal to Q star into CH by CB plus CH. So by using this formulation, I can calculate what is the optimum number of units being short. What is the optimum number of units being short? So if I want to calculate what is the maximum inventory level, M star is equal to Q star minus S star. So what is S star? That is this Q star minus Q star into CH by CB plus CH. So just placing this value, ultimately we are getting M star is equal to Q star into CB upon CB plus CH. Good evening, good evening. No problem. You can see in the recorded also at the end, right? The starting 1 hour, you can see in the recorded also. Don't worry about that. So by using this formulation, now we can calculate for the different models we have talked about. We have started with the basic EOQ, then we have talked about discount, then we have talked about the production, then this one is the shortage based model. Okay, clear? Perfect. Chalo. Now let's talk about we can say rest is, I think you can easily calculate. For probabilistic model, I think you already know we are using a static inventory. MSIN is the maximum inventory level. You can see in the graph also we have shown M is the maximum. So this is the optimum number of maximum inventory level. Optimum maximum inventory level. Okay. The optimum number of quantity, we can say maximum inventory level. What should the optimum value? Right. So now let us talk about quickly, because these were some major topics per CPM, your inventory. These are some topics where it is having formulation. Apart from that, we are having queuing model where we are having a lot of formulations. But from examination perspective, these are some topics that you should be having complete clarity. Now let us talk about. Okay, let me check. Have I included? Huh? Chalo, no problem. I'll be telling you. Now next one is sequencing. Let us talk about sequencing. Now sequencing is very basic methodology. Here we are doing 3 different types of sequencing. One is your we can say the sequencing of n jobs in a single machine. The second one is sequencing of n jobs on 2 machines, and third is when you're doing the sequencing of n jobs in 3 machines. So let us talk about the first one, when you are doing the sequencing of n jobs on 1 machine. So here we are having shorter processing time, earliest due date, critical ratio. What is critical ratio? Critical ratio is the ratio of due date divided by the processing time, and the slack time remaining is the difference between the due date minus the processing time. Okay, so what we are doing, we are arranging in the increasing order of the processing time in SPT rule. In earliest due date, we are arranging in the increasing order of the due date. In critical ratio rule, we are arranging in the increasing order of the CR value. And if I talk about STR, we are arranging in the increasing order of the STR value. Is this clear? Okay. But what's the speciality about these particular rules? I can simply say, if you want to have, now, let me give you some formulations. If I want to calculate what is the average number of jobs in the system, that is equal to the ratio of the total job flow time divided by the make span time. Okay, average number of jobs in the system can be defined as a ratio of the total job flow time divided by the make span time, right? I hope so you know what is job flow time, what is make span time. I'm not going into that basic understanding, because at this point of time you should be knowing about these terminologies. Okay, so if I talk about what will be the rule, minimum average number of jobs in the system, can you tell me which rule I need to use in order to calculate the minimum number or minimum average number of jobs in the system? You always need to use the SPT rule. Whenever we need to calculate what is the minimum average number of jobs in the system, we always will be preferring the SPT rule. And if I want to calculate what is a minimum average tardiness, we always try to prefer the EDD rule. We always try to use the EDD rule. Very important. If in the examination, if they are not mentioning about these terminologies, if they are not mentioning which rule you have to apply, right, there you have to simply understand from these 2 very important information. If they're giving in the question that's what is the minimum average tardiness, by default you have to use EDD rule. If they're talking about what's the minimum average number of jobs in the system, by default you have to use the SPT rule. Is this clear? Very important, right? Okay, now this is all about when we are doing the sequencing of n jobs in one machine. But let us suppose if we are talking about n number of jobs in two machines, there we need to apply the Johnson's rule. There we need to apply the Johnson, and Johnson's rule is very basic. What we have to do is 1, 2, 3, 4, 5, 6. Good afternoon, good afternoon. If the minimum value, if it is coming in machine number, if it is lying in machine number 1, right, then you have to allocate from the left hand side. Remember, if the minimum value, if it is lying on machine number 1, try to allocate from the left hand side. If it is coming in the machine number 2, try to allocate from the right hand side. Let us take one example. Let us suppose overall we are having minimum over here also and here also. As this is coming machine number 1, so you have to allocate from the left hand side. This is 6. Try to strike off. It is 3 over here. Okay, fine. The next minimum value is 3. This is coming in the second machine, so you have to allocate from the right hand side. This is 4. So strike off this. Next minimum value is 4 coming in machine number 1, so you have to allocate over here, right? Strike off this value. 6, 6. So it is coming in machine number 1. So this is 2, this is 5. The sequence that you should be following, that is 6, 1, 2, 5, 4, 3. And this is basically, we call it as a Johnson's rule. Okay. If the minimum value is coming in machine number 1, try to allocate from the left hand side. If minimum is coming on the machine number 2, try to allocate on the right hand side. If let us suppose you are having both as same, like in this case, we are having 1 and 1. Definitely we are having in the different. So we have to allocate over here. We can have one more possibility that, let's say in machine number 1, we are having two same values, right? Then in which will be preferring? In that case, we will be checking the value for machine number 2. Okay, let us suppose I could have one scenario like this. Let's say 5, 7, 5, 9. Let's say this is machine number 1 and machine number 2. Let's say this is A and this is B. So can you tell me which job will be preferred first? Okay. Which job will be preferred first, A or B? Can you tell me? A or B? Definitely, we have to prefer A. Why? Because once we are having this kind of situation, then we have to check the value in the second machine. So in the second machine, if you're having the least value, that will be preferred first. This is clear. A will be preferred, not B. Krishna was correct initially, but later on he was confused. Okay, and this is also vice versa also. That means if I say, if you're having a job, let's say 3, 3, let's say this is 6. So in this case also, in which this is your machine number 2, this is machine number 1. So tell me which job will be preferred. Which job will be preferred? Definitely we will be preferring job number D, but as we are talking in machine number 2, will be preferred at the end. Okay, this will be giving preference. So definitely we have to give him preference from the right hand side. So it will be D first of all will be allocated at the end, then we'll be having allocation of C. Okay, correct. Understood? These are some small points that you should be remembering. After this, you need to calculate, and the summation of this is your working time for machine number 1. The summation of this is working time for machine number 2. Okay, so I can calculate the idle time for any machine. The idle time for any machine is equal to the difference of the make span time minus the working time of that particular machine. Okay, make span time minus the working time. Let us write it completely. Working time. Okay, working time. This difference will be giving us the idle machine time. Okay, perfect. Clear? Understood? Correct. And if I talk about the percentage of utilization, I can calculate by your working time divided by the make span time. By using this into 100, this will be giving us a percent utilization of machine. Okay, percentage utilization of any machine. We can, because in normally in two machine job, they are normally asking what is the idle time or the percentage utilization. You can calculate by using this formulation. Okay, there are third possibilities. If you're having three machines, if you're having three machine, n number of jobs, n jobs on three machines. So in that case, what you have to identify, let's say this is machine number one. Let's say this is machine number one. This is machine number two. And this is machine number three. Okay. There are, let us suppose, three machines. Okay. So in this case, whenever you are dealing with three machines, you have to first of all convert into two machines. How we can convert? There is a condition. Condition is the minimum of value in machine number one should be greater than or equal to the maximum value in machine number two, or the minimum in machine number three should be greater than equal to the maximum of the machine number two. Either one of the conditions should be satisfied. If either one of the conditions is being satisfied, then you have to convert this into two machines. How we can convert? Let's say this is, I'm having some values. Let's say this is A, this is B, this is C. This is 2, 5, 3, 6, 3, 9, or let's say 8. This is 1, 4, 3. Okay. So we have to convert into two machine job. How we can convert into two machine job? That is machine 1 plus machine 2. So 2 plus 5 is 7, 5 plus 3 is 8. 6 plus 3 is 9, 3 plus 8 is 11. 1 plus 4 is 5, 4 plus 3 is 7. Now I have converted my three machine into two machine job. Now I can apply the Johnson's rule. Now I can apply the Johnson's rule over here. Okay. Now I can apply the Johnson's rule over here, and by doing so, now we can have the correct sequence. Yes. So in test series, they ask average tardiness. I calculate by SPT. Only it shows right only, but if you tell EDD, would be very no. If they are only asking to calculate average tardiness, right? If they're not mentioning what which rule, then they have. Then in that case, you have to check what is the given statement. If they are saying that calculate the average tardiness using SPT rule, then you have to apply the SPT rule. This formulation is applicable. If I say this particular. If you want to calculate the average tardiness, you can use SPT also, you can use EDD, you can use CR, you can STR. But if you want to calculate the minimum average tardiness, in that case, you have to use the EDD rule. Okay, there are two differences. If I want to calculate average tardiness, you can apply any method on the screen. But if you want to calculate minimum average tardiness, in that case, you must be using EDD rule. Okay, fine. If they are only asking average tardiness, in that case, you have to check. Not given, use SPT rules, sir. In that case, you have to check the question, right? Because normally, if they are not mentioning about anything, okay, if they are given the statement calculate average tardiness, they have to mention which rule you have to apply. Okay, either SPT or EDD, CR or STR. Normally, SPT and EDD are the two methods normally being asked in the examination perspective. Okay, clear? So you can send me that question in that case. Let me check from my personal end. Okay, chalo. So this is all about sequencing. Now let us talk about linear programming, a topic that some students might be having difficulty to understand. Okay, but I think this is a very easy topic, very scoring topic, linear programming, and then we'll be going with the queuing model, then forecasting, right? So still number of topics being left out. Now in linear programming, basically we are dealing with two approaches. One is your graphical approach, and is your simplex method. Simplex method, right? In graphical, we can only use graphical when we are dealing with two variables. If you're having two variables, we can use graphical. If you are having more than two variables, then you are bound to use simplex method. Okay. But in linear programming, we are not having as such any formulas. We only know the concept. So let me directly go with the special cases. Now here what we are doing is we will be having one objective function. We'll be having one objective function. Okay. We'll be having some constraints. We can have maximization problem or minimization problem. We'll be having some constraints with us. Okay, and we'll be having a non-negativity criteria. And we can easily calculate by using graphical use by plotting the graph, right? Now, how we can identify whether we are having infinite or multi-optimal solution? By using graphical. I'm talking about graphical first of all. By using graphical, we can simply say when the optimal value is obtained at multiple positions. Then I can say it is having an infinite or multi-optimal solution. Is this clear? Understood? Very easy. No solution means we are not having any feasible region. In that case, we can say we are having a no solution condition, right? If I talk about unbounded usually we are able to see in minimization problem, where you can have conditions like this. So in this case, the given feasible region is basically unbounded. Okay, it's basically unbounded. And fourth criteria that we have to understand is your degenerate solution. What is degenerate solution? Degenerate solution is when one of the basic variable is having a zero value. Any one basic variable is having a zero value. That particular solution we call it as a degenerate solution. Very easy. Now let us talk about simplex method. Now in simplex method, students do have difficulty, right? Now let us talk about simplex. Let us suppose I'm having a question. There's a spit now. Okay, fine. Okay, Kalyan. Let's say I'm having a formulation as some any maximization problem you have to calculate. Some equation is given and you're having, let's say, s1 plus 2x2 greater than equal to 10. Some constants is given. So what we try to do, we try to introduce the very important, we call it as slack variables. 2x2 plus s1 is equal to 10, right? So here the x1 and x2, this is, we call it as the decision variables, right? And s1, s2, this will be called as the slack variables. Okay, and this should always be positive value. This should not be having any negative value. The decision variable, the slack variables will be always be having this. Now in simplex method, what we are doing, it's an iteration process. So we try to plot some tables, right? We try to draw some tables, and by drawing the table, we are trying to identify some solutions. And whether that solution is optimal or not, we are doing some iterations, we are doing some exercises, we are having some entry variable, we are having some exit variable, we will be having some pivot element. Okay, so I think we already discussed this in the marathon also. Formula revision, we won't be doing this because I'm doing that particular thing, that will be again the same thing, repetition. Okay, but I'll be telling you some key points that you should be remembering. Let us suppose I'm having x1, x2, s1, s2, right? Let's say this is x1 and s2. By looking at this particular table, can anyone who can tell me which one is a basic variable and which one is the non-basic variable? Anyone? By looking at this particular table, anyone who can tell me which one is the basic variable or basis and which one is the non-basic variable? Anyone? By looking at this table. Because once you are able to understand like this, I think you are able to solve any question coming in the examination. Yes. Anyone who can tell me? There are four variables, x1, x2, s1, s2. Definitely the bases are x1 and s2, which is in the system. And we can say x2 and s1 are the non-basic variable. And normally the non-basic variable is having a value of, what's the value of non-basic variable? This is always equal to 0. the non-basic variables is always having a zero value. Is this clear? Okay, fine, because it is outside the system. Inside the system, we're having the basic variables or basis. Okay, yes, right. Now I'll be asking you a very easy question. I'll be asking you very easy question. Please do let me know. Let us suppose I'm having basis. Let's say x1, s2, x1, x2, s1, s2, and I'm having some values. I'm having some delta values as let's say 0, 0, and I'm talking about maximization problem. I'm talking about maximization problem, and this is negative, and this is negative. Tell me quickly, are we talking about optimum value or not? Yes or no? Please check. Are we talking about the optimum value or not? Anyone? Please do let me know. Quickly. Yes. How we can identify that? Yes. How we can identify that it's an optimum value? Yes, Ajay, Kalyan, yes, yes. It's very easy because the delta value is negative. That means if I try to, this is the non-basic variable, this is the non-basic variable. We always try to identify the delta value of the non-basic variable. If the non-basic value is having delta value to be negative, that means this system is an optimized. This is an optimal solution. This is an optimal solution because I'm talking about a Z max. Okay, fine. Now let us suppose I'm having one more scenario, something like this. Yeah, tell me, is this solution optimum or not? I'm having a condition like this. Tell me, is this solution an optimal solution or not? So always we try to identify the non-basic variable. So these two are the non-basic variables. These two are the non-basic variables, right? Okay, so tell me, for non-basic variables, we try to identify the delta value because delta value tells us about whether the objective function will be having an increment or decrement. It's an optimum only, perfect, an optimal solution. But as delta value is having a zero value for one of the non-basic variable, and that too a decision variable. That too, I'm talking about a decision variable, right? So I can say this is an example of a multi-optimal solution. Okay, this is an example of a multi-optimal solution. Okay, because the non-basic decision variable is having a delta value to be 0. So this is a condition for a multi-optimal solution. In graphical, it's very easy to understand, but in simplex, we can understand by using this particular logic. Okay, it is an example of a multi-optimal solution. Understood? Yes, Ajay, Kalyan, all good? Now, how we can identify for unbounded solution? If I talk about unbounded solution, right? For unbounded solution, we always check the value of theta. What is theta? Theta we call it as replacement ratio. Replacement ratio. How we can calculate theta? Theta is equal to value divided by corresponding key column, right? And if the theta value in the table, in the iteration, if the theta value is either all values are either negative or all values are infinity, or the combination of negative or infinity, in that case, the solution will be considered as an unbounded solution. The solution can be considered as an unbounded solution. Okay, the solution will be considered as an unbounded solution, right? And if I talk about the third condition, how to identify a no solution by using a simplex method. If I want to identify the no solution in the simplex method, it's quite easy. if in the final solution, if in the final optimal solution, if artificial variable is having a non-zero value, then we can say this kind of solution, we call it as no solution. Okay, if in the final optimal solution, if the artificial variable is having a non-zero value, then only we can say this kind of solution, we call it as no solution. And how we are getting this artificial variable? By using the big M method, right? I hope so everyone knows what is a big M method we are using. We have taken examples during our classes also, during our marathon also. So you can do have a revision of that. So just a quick understanding how we can identify no solution in using simplest method. If the artificial variable which I have denoted as capital A, if it is present in the final optimal solution, then we can say that kind of solution, we call it as a no solution. Right? Chalo. Now let us quickly talk about forecasting techniques, forecasting model. So there are different techniques that we will be using, right? We are having before that we have to talk about one duality also. We have to talk about duality also. Now in duality, what is happening? We are having a primal solution and we are having a dual of that. Right? So how we can calculate the duality? Just by converting, by transposing the rows into columns and columns into rows, right? Just by transposing the rows into columns. That means if you're having a greater than equal to sign, it will be converted to less than equal to. If you're having a maximization problem, it will be having a minimization. And what's the best part of duality? Why we are calculating this duality? The optimum value that we are getting in the primal will be exactly equal to the optimal value that we are getting in the dual. Very important. That is the basic importance of using this duality. Why we are calculating this duality is we are getting the optimal value by using primal as the same one as that of the dual. And that is the reason we are calculating this duality. Okay, fine. Now, let us talk about forecasting techniques. Now, there are two basic understanding. So let us first of all talk about the time series model, in which the first one is past average. By the name itself, past average means whatever data I'm having, I'll be calculating the average of that. I'll be calculating the only average of that, right? Not required. The second one is simple moving average. Simple moving average is basically you will be calculating the average only for some specific time period. Let us suppose if I say 3 month simple moving average. That means I will be calculating the average of the latest 3 months. That means if I say I'm having for any month value to be, let's say, having this value to be any value, this is 2, 3, 4, right? I'm having some values, right, for the individual months. So I'll be taking only the average of the recent three value, right? So this is basically called a simple move. This could be 5 month also, this could be 3 month, could be 7 month also. Normally from example perspective, normally you will be getting 3 months or 5 months. Okay, so simple moving average is nothing but you have to take the average of the demand only for some specific value. Past average means you have to take the average of all the values, right? Now, if I talk about weighted moving average, if I talk about weighted, in this case, I'll be assigning some weights to the recent data, right? That means if I say I'm having a January, February, March, April, let's say I'm taking 4 months, right? Having some values. Okay, some demand values we are having 2, 3, 4, and they're asking what is the forecast for the month of May, right? So in this case, I'm talking about, let us suppose 3-month moving average. Now I'll be assigning maximum weightage to the April and the minimum weightage for the oldest value. So for that, you need to calculate what is the weights. Now how we can calculate weights? Weights is equal to we can say summation n. How we can calculate summation? That is n into n plus 1 by 2. N into n plus 1 by 2. And we can calculate this weights as, I can calculate this weights as we can say n upon summation n minus 1 upon summation n 1 upon summation. Let us take an example. Let us suppose I'm taking 3-month moving average, 3-month weighted moving average. So what will be the weights? Let us calculate summation n. Summation n will be equal to 3 into 4 by 2, that is 6. So we'll be having the weights of we can say 3 by 6, 2 by 6 and 1 by 6. This will be 3 different weights. So I'll be assigning the maximum weight to the latest for March and 1 by 6 for the Feb. Is this clear? I'll be assigning the highest weight to the recent data and the lowest weight to the oldest data, right? So by this way, I'll be able to calculate the weights and you can directly calculate the forecasted value, right? Fine. Now, the very important in our forecasting techniques is the exponential smoothing. Now, in this case, we'll be defining one very important term which we call it as the smoothing constant. Smoothing constant, right? So I can say the forecast for any time period t is equal to the forecast for the nth time period plus alpha demand for the nth time period minus forecast for the nth time period. This value, by using this particular formulation, we are basically able to calculate the forecast for any month just by knowing the previous value. Just by knowing the previous value, we can easily calculate. And what is this d? Let's say di minus fi for any time period. I can say this is nothing but error. This is, we call it as error for that particular time period. And if any question, if they are not mentioning what is the value of alpha, then we can use this particular as 2 upon n plus 1. By using this formulation, we can calculate the smoothing constant if they are not mentioning. If they are giving the value, then it's okay. If they're not giving, then you have to use this formulation of the smoothing constant as 2 upon n plus 1. Okay, fine. Apart from this, we are having some forecast error that we need to understand. Just now we have seen what is forecast. This is nothing but the difference between the forecast demand minus forecast for any time period. We can say the error for any time period t is equal to the demand for that time period t minus the forecast for that time period t. So over here, we'll be calculating 5 different unknown parameters. The first one we call it as mean absolute deviation, which we always called as MAD. By the name itself, we can say mean absolute. That means we have to take the only positive value. So mean absolute deviation is nothing but the summation of I is equal to 1 to n mod of di minus fi divided by n. You have to take only the positive value. You have to take only the positive value of the error, right? And mean absolute deviation only tells about the magnitude of error. Magnitude of error. Okay, fine. If I talk about the second one, that is mean forecast error or bias. Bias is having almost the same formulation, but here I'll be calculating the exact value. That is di minus fi divided by n. So here I'll be including the negative value also, right? So from here I can say if bias is negative, can you tell me what is the meaning of that? If overall the error value on an average is coming out to be negative, that means always I am forecasting more than that of the demand. That means I'm having over forecasting. I'm always doing over forecasting. Okay, if the bias is coming out to be a positive value, that simply means I'm always doing under forecasting. That means demand is always higher than that of the forecast value. Under forecasting. Okay, fine. And we can also call running some forecast error. Running some forecast error, which I'm calling it as RSFE. So what is RSFE? RSFE is equal to the numerator of bias. That is summation of I is equal to 1 to n di minus fi. Okay, or I can say, or we can say that bias can also be defined as the ratio of running some forecast error divided by n. Divided by n. Is this clear? We can calculate this by using this formulation also. The third one is mean square error. Now, why we are calculating this mean square error? Because ultimately we need to calculate the standard deviation. That is the only significance of using calculating this mean forecast error. So mean forecast or mean square error. Mean square error is equal to summation of I is equal to 1 to n di minus fi whole square divided by n, right? And after calculating this mean square error, we can calculate the value of standard deviation. Standard deviation, that is equal to under root of mean square error. Just like we have calculated the variance, right? It is having the same significance. The mean square error will be telling us about the level of uncertainties that we are having in the forecasting value. If the mean square error is having a larger value, that means we are having large or higher uncertainties, okay, in our forecasting versus demand. The next one is mean absolute percentage error, which we call it as MAPE, M-A-P-E, which is equal to summation of I is equal to 1 to n di minus fi by di into 100, okay, divided by n. So this will be giving us the value of mean absolute percentage. Why this is being calculated? Because there's a difference between, if you are calculating, let us suppose the value of error is, the average value is coming out to be 40 in one case, in second case also we are getting 40, but one case it is 40 out of 100, second case is 40 out of 1000. So definitely the case number one is 40% error we are getting. In second case we are only getting 4% of error. So it's always, we need to understand there is a huge difference between what is a percentage. In percentage error we are able to calculate what is the actual variation which is happening, okay, because there's always a difference between, if I'm having, let's say, 30 out of 100 and 30 out of 1000, it's having a huge difference. 30 out of 100 means we are having a 30% variations. 30 out of 100 we are having only 3% of variations, okay. So in order to tackle out these particular problems, we are calculating this mean absolute percentage of error, okay, fine. And after this we are talking about the last one, that is tracking signal. What is this tracking signal? Tracking signal is basically, I can say, tracking signal is equal to the ratio of we can say the summation of I is equal to 1 to n di minus fi, right, divided by mean absolute deviation. Yes, divided by mean absolute deviation. So why this is being calculated? The tracking signal basically help us to identify whether the forecaster is able to forecast the correct value or not, okay. We can say this is also equal to running some forecast error divided by the mean absolute deviation. That is the tracking signal. And ideally it is being seen that for ideally it should be having a value of, ideally it should be having a value, tracking signal should be having a value of 0. If you're having a 0 value, it's perfect. But if you're having between plus minus 3 to plus minus 5, then we can say it is a good forecaster. If you're having a value beyond this, let's say we're having minus, plus minus 8 or plus minus 9, that means that forecaster is not able to forecast accurately. So that is the reason we are calculating this tracking signal in order to identify whether the forecaster is performing its job accurately or not. Okay, that is the significance of this tracking signal. Okay, fine. Chalo. So this is we can say all about your forecasting. The last one is queuing model. I think after that we will be winding up the session. I think. Let me check. Queuing model. Okay, let's quickly have a discussion on this queuing model. Right, just 15 minutes more, then we'll be winding up the session. Okay, so queuing theory in this case, what is happening, will be having some, it is always being implemented in a service organization where we where the server is providing service and the customer is taking service from that. Okay, the best example that we have already seen in the food chain, like, or the food counters like KFC, McD, right, or we can say banks, right, ATM machines. So there we are implementing this queuing theory. And what is the significance of this? It is basically helping us to identify what is the we can say the balance between the cost of providing service and that of the service time. That means if a customer is waiting for some small time period, is that justifiable? Sometimes the customer has to wait, sometimes the customer is not allowed to wait. So that particular, we have to make an economic balance between the cost of providing service and that to the service time. So here there are some terminologies, exactly like in temples we're having VIP access. Also in some temples you might have seen there are some VIP access. If you're having a VIP pass, you should not be waiting for that long queues. If you're not having any VIP passes, then you have to wait for 3 to 4 hours, right? Even for 1 day or so. Okay, you're having this kind of scenario, right? Okay, fine, exactly. So now let us talk about, there are some terminology that we'll be using. Lambda is basically, we call it as arrival rate. Arrival rate. The unit is, and here you always try to understand the units. It is customer per hour. Okay, this is your service rate. Service rate, that is customer per hour. So here I am introducing a very important term which we call it as utilization factor, denoted as rho. It is equal to the ratio of lambda by mu, and this is always less than 1. This is always less than 1, right? So what is this utilization factor? If I talk about this utilization factor, that is rho, it is lambda by mu. Can you tell me what is the significance of this utilization factor? Anyone? What is the importance of this? This rho value will be telling us about, it is a percentage or the probability that the server is busy. That the server is busy. Very important. Transportation assignment models, I think for that there is no particular formulas for that. We have to solve the questions, right? And I think already we have discussed that, so there is no requirement of taking the transportation and assignment. There is no particular formula, there is a complete method. Okay, fine, don't worry. If you're having any doubt, please do ask, no problem with that. So rho basically signifies what is the probability that the server is busy. Okay, please give a short explanation of Vogel's approximation. Perfect, I'll be telling you about Vogel's approximation, don't worry. Probability the server is busy, or we can say that the probability that when a new customer is coming into the system, he has to wait. When a new customer is entering, has to wait. Okay, fine. Is this clear? The rho value signifies what is the probability that the server is busy, or the probability when a new customer entering the system has to wait. Now, this is all I'm talking about probability. So I can say what is 1 minus rho. It is basically, we call it as a probability. There is a probability that server is idle. Server is idle. Or I can say the probability that new customer does not have to wait, right? Or I can say, can we say that this is the probability of zero customer? Very important, because in the examination you are getting questions directly from this. Okay, so this is basically, we can also denote as P0. So P0 is equal to 1 minus rho. That is the probability the system is idle. Probability is zero customer, which we can say P0 equal to 1 minus rho. Okay, fine. Fine. So now we can say what is the probability that there are n customer in the system. So Pn is equal to rho to the power n into P0. So by using this particular calculation formulas, we can calculate what's the probability that there will be exactly n customers in the system, right? If I say there are, what's the probability there are 2 customers in the system, that will be rho square into P0. What is P0? P0 is equal to 1 minus rho, right? But let us suppose if I'm asking you a question, what is the probability that at least 1 customer will be present in the system? Because we know that P0 plus P1 plus P2, this always will be having, the summation will be having equal to 1. So if I'm asking you what is the probability of at least, let's say, 2 customers in the system. Can you tell me what is the probability that at least 2 customers will be present in the system? Anyone? So here, what is being included? 2 customers, 3 customers, 4 customers. So it will be going on till infinity. So how we can calculate that? We can simply say this is also equal to 1 minus P0 plus P1. What is P0? That is, we can say 1 minus rho. What is P1? That is rho into 1 minus rho. So by this calculation, we can calculate the probability of at least 2 customers in the system. We can have a different condition, like what is the probability of having at most 3 customers? Can you tell me? Probability of having at most 3 customers. Yes, please write in the comment section. What is the probability of having at most 3 customers? That means I'm talking about P0 also. 0 customer is also valid. 1 customer or 2 customer or even 3 customer, right? So we can now calculate this is P0 plus rho into P0 plus rho square into P0 plus rho cube into P0. So by using this particular formulation, we can calculate what's the probability of having at most 3 customers in the system. Exactly. P0 plus P1 plus P2 plus P3. Okay, apart from this, there is a very important calculation that they're asking is what is the average number of customers in the system, which I'm calculating as LS. So what is LS? LS is equal to rho upon 1 minus rho. Rho upon 1 minus rho. Okay, or we can say this is equal to lambda upon mu minus lambda. We can write it like this also, right? But usually I prefer this particular formulation because we won't be having any difficulty to understand. Okay, fine. If I talk about what's the average number of customers in the queue, which you are denoted as LQ, so LQ is equal to rho square upon 1 minus rho, or I can say this is equal to rho into length of the system. Okay, we can calculate by any formulations. Clear? At most means you can have maximum 3 customers. You can have at maximum 3 customers. So we can have a condition of 0 customer, 1 also, 2 also, and 3 also. Is this clear, Shivakumar? So if I say at most 3 customers means I should be having max to max 3 customers, not more than that. So 0 customer is also applicable, 1 also, 2 also, 3 also. That means we have to take the summation of this. That's it. If I've been writing like what is the probability of having at least 3 customers, then it will be 1 minus P0 plus P1 plus P2 plus P3. Okay, understood? There's a difference between at most and at max. Fine. Or if you're having confusion, let me write it like this. What's the probability of having maximum 3 customers in the system? Now good. If you're having still confusion, we can write it like this. Fine. So 0 also applicable, 1 also, 2 also, 3 also. Chalo. Now, next is your Little's law. In Little's law, we are trying to identify we are trying to identify very important understanding, that is a waiting time of the system. Waiting time of the system is nothing but the length of the system by the arrival rate. Okay, this is your waiting time of the system. Waiting time of system, right? Similarly, if I want to calculate what is the waiting time of the queue, that is the length of the queue divided by the arrival rate. This is the waiting time of the queue. Time of queue. Okay, or in queue specifically, I can say. Right, very important, because maximum number of time, again I'm repeating, question is being repeatedly asked either from the length of the system, length of the queue, or waiting time of the system or waiting time of the queue, right? Fine, which we are basically talking about the latest law. Now, apart from this, there are some other formulation, empirical formulation. Let us try to understand what is the probability that there are more than t time period requires to service a customer, because we know that it's always a negative exponential. So probability of having more than t time period is e to the power minus mu into t. Always remember, if your mu is having a unit of customer per hour, so you have to take the time period in hours only. You have to take the time period. Let us suppose if it is given in customer per minute. Let us take an example. It is given in customer per minute. Then you have to take the time period in minutes only. Okay. So it depends upon the unit of mu also, because exponential to the power will always be a unitless parameter. Okay. So probability that more than t time period is required to service a customer, it is equal to e to the power minus mu into t. Now, the second formulation, empirical formulation, is the probability that waiting time in the queue is greater than that of t. So waiting time of the queue is greater than that of t is equal to rho times e to the power minus t by ws. Again I'm saying, if the ws is in hours, t will always be in hours. Okay. So by default, if you are having the ws in hours, so you have to take the t in hours. Always try to convert into hours only. You won't be having any difficulty. There's a common mistake the students are doing is, you will be calculating the waiting time of the system in seconds or in minutes, and the time period will be given in hours. If you're putting that value as it is like this, you'll be getting the wrong value. Okay. So try to convert into the SI unit, that is hours. Won't be having any difficulty. Right. Now, the same thing, what is the probability of wait in the system is greater than that of t, right? What is the probability that waiting time of the system is greater than that of t? It is only rho will be eliminated, e to the power minus t by ws. Here we are having rho times e to the power minus t by ws. So by using these two formulation, we can calculate the probability of waiting time more than some time period. Now, what is the probability that n arrival in the system during some time period t is equal to e to the power minus lambda into t to the power n divided by n factorial? Very rarely being asked. A question was asked directly from the formula, like they were giving some formulations. So you have to remember this formula also. Okay, fine. So these were some discussion of the queuing model. Now there was one doubt from Vogel's approximation, right? So let us take the Vogel's approximation specifically on demand. Let us talk about Vogel's approximation. Okay, in your transportation model. Okay, I'm talking about transportation model. Now in Vogel's approximation, what we do, we try, this is also called as your penalty method. Okay, we try to calculate the penalties. What is penalty? Penalty is basically equal to the difference between the second minimum and minimum. The second minimum value minus the minimum value. We try to calculate the penalties, row wise also and column wise. So once we are calculating the penalties, we try to identify. There are simple. First step is try to calculate the penalty. Second step is identify the maximum value of penalty. Among all the penalties that you have calculated, identify the maximum value and try to have maximum allocations possible in that corresponding row or column. Whatever you are having, either in row or in column, wherever you are having the maximum value of the penalty, identify the maximum penalty value, right? And by doing this, we'll be having the Vogel's approximation. And in examination, try to use Vogel's approximation method. If they are not mentioning about anything, then try to apply this Vogel approximation method, because it will be giving us more accurate value or more accurate results. Okay, fine. Is this clear? Right. So apart from this, we are having Modi method. I think Modi method, we are having UV method. You try to calculate U and V, and just by calculating the opportunity cost matrix, you are trying to identify whether our solution is optimized or not. Okay, for that also I have given one in marathon. So we are not having a direct formula. This is a complete method, so you can see that session also, right? So this is all the formulas that we are having in our industrial engineering. Almost we have seen, because there are multiple segments in industrial engineering where there is not formulas we are dealing with, we are talking about some methods. Like in transportation, we are having northwest corner rule, your row minima, column minima, Vogels approximation. We are having Bodhi method, we are having skipping stone method. So these are not having any formulas, we are having some methodologies, right? So try to solve only one question, more than sufficient, right? And I'll be sharing this PDF just after this, just after the completion, I'll be sharing this. And please do try to give a positive attitude, because only 3 days is left out. Today's day is gone. 3 दिन बचे हैं for examination. Try to be positive, try to be stay motivated. If this point of time, if you're having any topic that you're not confident, just leave it. Don't worry, just leave that topic. Don't worry about that, because there is no time to again start a new topic. Okay, try to revise whatever you have studied. If you have studied only 70% syllabus, okay, just you have to remember, are you able to remember that 70%, 100%? क्या वो 100% remember कर पा रहे हैं? If you have studied 70% syllabus, are you able to recall completely that 70%? That is important. Okay, syllabus completion is not all never the objective for GATE examination. Understanding of concept and how you are able to apply the logic, that is important. Okay, so thank you guys. Sir, one doubt, when they need use the waiting time for queue and system, for sometimes it is being now let us suppose there is a statement that what is the waiting time of a product before being serviced. Let's say this is the statement. Can you tell me what they are asking? If my question is what is the waiting time of a product before being serviced, that means I'm talking about before reaching that service counter, what is the total waiting time? That means I'm talking about the waiting time of the queue. Okay, so try to read the statement. In industrial engineering, statement understanding is very important. If you're having that, then only you will be able to go to the correct answer. If you are not having that understanding of that correct statement, then you won't be able to understand what they're asking. Okay, fine, correct Ajay, absolutely correct. Fine, so thank you guys for joining with me. I hope you all enjoyed, right? Please do subscribe to this channel and do like and share this video to all of your friends. Thank you guys, bye bye, take care, stay safe, and have a great exam ahead. Thank you, bye bye, take care.